Hey, fifth graders, it's Mrs. Seals back for our next science lab. Last week we started talking about energy with sound energy. This week we are moving on and talking about another type of energy called thermal energy. So let's get started. Your target says I can explore the uses of energy, including thermal. So hopefully you remember that energy is the ability to cause change or do work. And I gave you an acronym or a word with 5 letters. Each letter represents another type of energy that we will be discussing in 5th grade. That word is melts. So we have M, which stands for mechanical energy, which we'll be talking about in a couple of weeks. We have E, which stands for electrical energy, which we kind of touched on a couple weeks ago with electrical conductors and insulators, but we'll be talking about it again here in the next couple weeks. Light energy, we'll also be talking about that. Thermal energy, which means heat, which is what we are discussing today. And then sound energy, which we talked about last week. So what is thermal energy? Thermal energy is energy related to the temperature of an object or a substance. So in other words, the higher the temperature, the more thermal energy is in an object. It's measured as temperature with a tool called a thermometer. Thermal energy moves from the warmer substance to the cooler substance. And the movement of thermal energy from one substance to another can result in a change of state, like solid, liquid, gas. And that's talking about melting, freezing, evaporation, condensation. All of those changes involve thermal energy or heat being added or taken away. And that can change solid to a liquid, or a liquid to a gas, or a gas to a liquid, or a liquid to a solid. We're going to kind of talk about that here in a minute. How is thermal energy used in our everyday lives? So quickly think about some different ways we use heat or things that, we rely on heat for. See what you can come up with. There are many ways that we use thermal energy. Here are a few I thought of. We use it for cooking. Anytime you are cooking something on your stove, in your oven, in your microwave, in your Instant Pot, in your crock pot, any of those things that heat up food, that involves thermal energy because it involves heating. We use thermal energy to heat up our homes, whether it's through a fire in the fireplace or, the heat turning on the heater. We use thermal energy to dry our clothes in the dryer because the dryer gets hot. We use thermal energy in lots of different ways. When we blow dry our hair or straighten or curl our hair, those tools all get hot. That is thermal energy. When we iron our clothes, all of that involves thermal energy. When we make s'mores. All right, so today we are going to do an investigation with thermal energy. And we are going to see what happens to a popcorn kernel when we heat it up or add thermal energy to it. So the way we're going to do this is our heat source or our source of thermal energy is going to be a candle that I will light in just a minute. I have a test tube here that I'm holding by a test tube holder so I don't, burn myself. And in it, I have a little bit of cooking oil, which is just going to help get it heated up faster. And I'm going to add 1 popcorn kernel. Ooh, and add it to my test tube. So what I'm going to do in just a second is I'm going to light the candle and I'm going to hold the test tube with the popcorn seed over the candle so we can watch what happens, and then we will have a discussion about what happens. So before we start, I would like for you to make a hypothesis. What do you think is going to happen to the popcorn kernel when I heat it up using this candle? Make your prediction. And before I start, I want to remind you, whenever we are doing an experiment with an open flame, we are taking extra safety precautions. Remember a couple weeks ago when we did the thermal thermal conductors activity with the conductivity star and the different types of metals. So I have water nearby just in case I need to put out a fire quickly. I have a thermal blanket back there by the door. See it right there? Little bitty. It looks little from here. There is a fire extinguisher just in case something gets out of hand. I'm also going to kind of tie my hair back out of the way just so I don't accidentally, turn my head quickly and, get my hair in there. But we shouldn't need any of this, okay? These are just extra precautions that we take to be safe. Also, one more thing, please remember that this is not an experiment to do at home by yourself. You probably don't even have a test tube and a test tube holder, but even if you did, please make sure you are not doing anything with fire at home by yourself, okay? So let's get started. We are going to see what happens to our popcorn kernel. Also, after I get it going, I want you to see if you can listen very carefully, and I will also kind of explain anything that's happening in the test tube because it might be hard for you. So lighting my candle. There we go. I don't know. Can you see that it's lit? I don't know if you can see that. My candle is lit. I think it's kind of hard because of the sun. I'm going to hold my test tube holder. All right, let's see what happens. So I don't know if you can see, but the oil is starting to bubble up. It's getting hot. Don't know if you can hear, but we can actually hear the bubbles as well. The oil's still bubbling. It's starting to bubble more. Whoa, that scared me. All right. So let me blow out our candle so we can talk about this. Holy moly. All right, so let's talk about what happened. Oh, I wasn't ready. I thought it was going to take a little bit longer. Let me get a tissue. See if I can get our popcorn out of here. There we go. All right, so let us talk about what happened in our experiment. So look at my popcorn kernel now. It has popped. It is now a piece of popcorn. So let me explain to you what happens, because we have an example here of how thermal energy can change the state of matter of an object. Not that our popcorn kernel changed. A popcorn kernel is a solid. Our piece of popcorn here is still a solid. However, the change is what happens inside the kernel. A lot of people don't know this, but inside of a popcorn kernel, there is a teeny tiny little bitty amount of water, which is a liquid. Think about what happens to water when it is heated up, or any liquid when it is heated up. Hopefully you remember that when liquids are heated up, they turn into a gas. That's called evaporation. Think back to a couple of weeks ago when we were talking about solids, liquids, and gases, and we said that one characteristic of a gas, oh my goodness, excuse me, I got the hiccups. One characteristic of a gas is that they like to expand and spread out very, very far. So what happens inside this popcorn kernel is that when the water is heated, in this case by my candle, it turns into a gas and it expands, and that causes the kernel to turn or flip itself inside out. So this white part of the popcorn was actually from the inside of the kernel. And when that water changed into a gas and expanded and wanted to spread out, it flipped the kernel inside out. And this is the popcorn that we see and that we eat. So we saw an example of how thermal energy, number one, is used in everyday life because we use thermal energy to cook our popcorn, right? Whether you cook it in a microwave or on the stove or over a campfire, you are using thermal energy to cook your popcorn. And we also saw an example of how thermal energy can change the state of matter. The water that was inside of this popcorn kernel was changed from a liquid to a gas, which caused the popcorn kernel to expand. All right, I hope that you enjoyed that experiment. Please remember, do not do this at home. Please remember, after this video, there will be a short quiz in Schoology to see what you know about thermal energy. It's not for a grade, it is optional. However, I hope that you had fun, and I will see you next week when we talk about another form of energy. Have a good day. Bye, guys.